Welcome to the computer graphics practice video, and the task is path trace, and this video is the same for JavaScript and C++. And the reason for this is that this task has no base code. Rather, you should use your base code or solution from the Rejection task and build on that. Remove some of the things, add some of the things, and modify it. So depending on what did you do there, this task may vary, and it's pretty much similar in JavaScript and C++ anyway. At least the things you need to do on the application side we have done in both of those languages sufficiently, so and there shouldn't be something new to cover. But let's start from the beginning. So path tracing is this random sampling method where, similar to ray tracing, we shoot rays out from the camera into the scene. But now when a ray hits some triangle, so hits it here, we do random reflection based on the surface normal and the hemisphere on that triangle. So let's say the surface normal is this, there is this hemisphere here, so on the direction of the surface normal, and we'll do if the ray came in this way, then maybe it randomly bounces that way. Maybe it bounces this way, who knows. But basically we find the random direction in that hit point based on the surface normal and the hemisphere, and send another ray from this point to another location. And we could do this recursively how many times you want. In this task, once is quite enough. And the effect you might get here is that if you have, let's say, a red triangle here or a red wall or something, then the reflected or the bounce ray that now hits this red triangle, when you recurse back, or when you find what did this bounce ray hit, you get that it hit a red triangle, you get some amount of red color from here. And if this triangle here happened to be let's say white or something, not green, then the red color is now apparent on this pixel here. And even though this is not a light source, it's just another object in the scene, it now contributes some of its color to this triangle as well. So this is the whole idea between global or indirect illumination, and this is what you should try to get in this path trace task. It doesn't have to be this perfect, you have 1 million bounces and different iterations, okay, not 1 million bounces, let's say 1,000 bounces and million iterations. It doesn't have to be that. It can do let's say 1,000 iterations and 1 bounce or something like this, and that's already fine if it displays the one layer of indirect light. This task has all sorts of different components. So one component is that the chopper scene that you had before isn't really useful for this, or it doesn't demonstrate this solution very well. So one part of this task is to be creative and create your own scene. And you might want to create a rotation functionality in the create cube function. So you might want to rotate your cubes around to make this some kind of a reflective place somewhere. So for example, you would have this big red wall that's reflecting all sorts of red light this way, and then you have some white cube that catches that light. So this rotation might be interesting, and you should also compose the scene in a way where this indirect illumination is visible. For example, here, this face would be rather black, but here I can see that some of the red light is bouncing from the front wall. Although this isn't all that nice of a solution, there are much better solutions that visualize this thing better. Even like I think if you put some white and some other brighter colors or different hues here, you might get some cool effects. Now, but coming back to this random bounce, so the whole idea is that you do this random bounce and then you get some result and you average those results over multiple frames. But even with this random reflection, there's already something interesting going on. So if you have a ray entering some point on a surface, then how do you do a random reflect here? So if you would just say that, okay, my new random vector is something like 0, 1 square or -1 to 1 square, actually not square but even cube because we're in 3D space, then this already gives you several problems. First of all, how do you do a random reflection on a hemisphere? So to solve this, you could, one example is to generate lots of those, not lots, but let's say have a loop with some like 10 iterations. And the question is, if you have generated, like your normal is here, and your first iteration generates a vector here. So that's not to the same side as the normal. So you discard that and you go to the next iteration of your loop. In your next iteration of your loop, you might get a random vector here. That's not to the same side as the normal either. So discard that as well. And a third iteration of the loop. And in the third, you might get a vector here. And that's to the same side as the normal. The angle between the normal and the newly generated vector is less than 90 degrees. And that's all good. Use that normal to that random vector to assign your new race direction. So this could be one way that you just try it like 10 times should be enough. If in 10 times you don't get anything to the same side as your normal, you're really unlucky there, and discard that result then. Like just, I don't know, output the last vector or output some fixed vector or something like this. It's not going to affect the result anyway that much, because the chances are that in 10 times you will very probably get one of the vectors that's to the correct side of this hemisphere. Now another problem is this thing. If you just create a random value that has like random from -1 to 1 in x, random from -1 to 1 in y, and random in -1 to 1 in z, then you're not actually creating random values from a sphere, but you're creating random values from a cube. And that gives you more probable values towards the corners than it would do on a sphere. Now you have a couple of choices how to solve this. One way is, if you have this loop again, then check that and now you need to be clever how to check this, that your randomly generated vector is in this part. It's inside a unit, not a unit, but inside a cube, but not inside a sphere. And if it's here, then discard that as well, try again. But there are other ways. So for example here, there's a link how to pick random points from a sphere. There are, I think there are 3 or probably 3 different ways to do that. So you can implement any one of those and see what happens. Or you could try to come up with your own solution. Now I have samples here, your solutions should look like this one up here. Not like that one, that has something wrong with the point generation. Of course, like in order to see, is it really like this, you would need to use your method to generate points and then project them into 3 planes, axis planes, and see if this, after a good number of generations, you get a uniform sphere-like thing in all of the projections. For example, here you don't. And if you sample from a cube, then you're going to see something like this, that you can see that there are more values appearing on the diagonals here and on this area as well, which is like the top corners of the cube and top face of the cube that you're sampling from. So this is not a uniform sphere sampling either. So try to avoid this situation. This is not a random reflect. It's best to reflect towards the corners and the edges of a cube. Now another question you might have is how to even create a random from like even from this -1 to 1. Then there is this link here. So in the fragment shader random reflection, check out this site, and this site opens basically this link that says that in order to get the random value in the fragment shader, do not use this, use this. And if you use this, then you're all set. So if you remember the Berlin Planet solution, or one interesting thing you can do there, which is sent to the mailing list. There I also used this random value generator, and I actually used it like this. There's the function, right? And the goal was that I needed to create a random vector from an input vector. So what was in the base code was this function, but that one for some reason worked differently in the different shaders. So I tried this one. Now the function you have here returns one float and wants a vec2 input. So I just created a new vec3 where I send like the xy, yz and cx coordinates of my input vec3 and get out as a random vector. But so this is one way you can kind of use this function to get the random vec3 from some input vec3. And this is also like now a chance for you to think how to use this function to create those random vec3s based on some input. Now the input you can use here is, for example, the position of this hit point, like the x, y and z coordinates of this position, and also time. So the idea is that you don't want the hit or the reflect here in the same hit point to be the same every time. This brings us to our next topic here, that the idea how path tracing works is that you create different random reflects and you average them together. For example, the first frame, so to say, does reflect this way and samples whatever is there. The second one maybe reflects exactly back here and samples whatever is here. The third one maybe goes this way and samples whatever was here. And then you get like all sorts of different values, and it will be very noisy. And you can also see this in the CG materials through global illumination. And initially it's noisy and converges into some values quite soon. 2 pounds converges a bit slower, but still. So this is something, this averaging part is also part of this task. So for the averaging part, you need to create 2 textures. So one is, and you'll flip between them. So one texture will be the one you will show to the viewer, and the other one will be the one you will use like as an input. So what I mean by this is that, let's say you have like texture 0, texture 1, and let's put 1 as here. So and let's have this is all done in one frame, basically, or one like one draw loop, or one like iteration of the draw loop. So draw loop, and let's say that you have here the GPU that runs through the pipeline, and what we'll do here is that basically this will be the path trace shader, and we will get in the zero texture or the zero render target, and it will render to the render target 1. Now, during the same loop, after this has been done, you can just use the render target 1 to render whatever is on that render target to the screen. So this GPU just outputs to the screen, and this will be just regular texture mapping or texture sampling of the texture. So it's same thing you did in the UV mapping task. You just get some texture as input and you just output it. This is for you to like actually be able to see what's going on in this path trace loop. And then what you're going to do is you're going to exchange 0 and 1 with each other. So next time, this 1 that was the output of the path trace this time, and you showed here, will be the input of the path trace in the next iteration, and then it will output 0, and 0 will be in the input of this just regular texture rendering to the screen. So this is an interesting thing you can do here. And you have used like the second 2 frame buffers in the soft particle chopper, where you rendered things in the depth kind of space into this intermediary frame buffer, which you used as an input to the next pass during the same frame. So it's pretty much like using the same approach there. So two textures or 2 render targets and flipping them each iteration. And you might also want to create 2 scenes. So one is like this path tracing into the texture, and the other will just render the texture. So, but it doesn't. This is something you'll have to see if you need this. Maybe you can just exchange the texture of the quad, and that's done. Yeah, and like I said in the beginning, change the scene accordingly. Chopper with rotating plates is not a good idea, because you need to average those samples together. If the plates keep rotating, then like your whole averaging is lost. So don't have any moving parts. You can just cut out the entire update chopper method. You don't need any of that. You don't even need the chopper. Just put some cubes or spheres or different shapes that show this indirect illumination in some form. It would be very good if you kind of describe where is your indirect illumination in the submission. So in the application side, all of those things you have either done before or are easy, like in this sense, add uniforms for the time and sample weight. So you just add 2 uniforms to your application side. And time you can get with GLF get time or a 3JS clock class, and sample weight. This is a float, and this is where this averaging thing comes in. The entire idea, like I mentioned in this path trace, is that we get this 0 as input, but in this part we need to now we find like a new sample that comes in here. new sample, and we need to mix this new sample in with the already calculated set of samples, or the average of the current previous samples, the running average. And to get this, there is this, let's see how we should kind of put together this new sample and our previous running average. So I'm going to start from here. So what is an average? Average is the sum of, let's say, A0 plus A1 plus and so on until AN, and this is divided by n. So the sum of all the values up to n, which is divided by n. This you should know. And now what happens if let's first multiply this with n. So we get that n times the average will be the sum of A0 until AN. And now what we want to do is we want to add n plus 1. We have a new sample. So let's add it. Let's add it to both sides. So we get n times average plus AN plus 1 is equal to A0 plus until now AN plus 1. This is our new sample that we just found, and we have added it to our kind of average. This is just a mathematical idea here. So now in order to get the new average, we need to also divide this thing, with n plus 1, right? Because if we divide the right side with n plus 1, well, then we have the new average. And this is how the average is defined. It's from 0 to whatever value divided by the number of those values. So if we divide this with n plus 1, we get the new average. And this gives us this interesting thing that we have n times the previous average plus the new value divided by n plus 1 is equal, and you can see that the right part is exactly the average of n plus 1 elements. We are left with this formula. And with this formula, we can make it a bit better. If you look at now this left part, and I'm gonna write it here. If you look at the left part here, then we have, and let's divide this through. So we have n divided by n plus 1 times the previous average plus 1 divided by n plus 1 times the new sample. And this entire thing is the new average with n plus 1 samples. And you can see now this very clearly says how do you add a new sample to an already existing average to get a new average with one more sample. And if you look at the values n plus 1 divided by n plus 1 and the other coefficient here, and you add them together, n plus 1. And this, what will this give you? This will give you n plus 1 divided by n plus 1, well, which is 1, right? So you can use the GLSL mix function, which you have to look up the order, but takes like values a and b and one like coefficient which can blend linearly between those two. And if you put now this one of those, I don't know which one has the coefficient here, a will be the current average value and b will be the new sample value, then you will get out new average with one more sample. This is how you can implement like keeping the running average and adding new values to this running average each pass here. So you take the current average, you add the new sample, and you get out the new average, which has one more sample. So use this mix operation with those coefficients and those values that you blend together, the previous average and the new sample, and you get the new average. Okay, this is of course also explained here, and this should be pretty much it. So remember, don't have any moving parts here. Try to figure out how to do a random reflect on a hemisphere based on the surface normal. So your ray hits some triangle, this triangle is normal, this normal has a hemisphere around it. You need to find a random point on that hemisphere to create a new random direction for the new like bounce ray. Then bounce that ray to a new ray cast, for example the JavaScript solution, but this is GLSL, so it's the same. Instead of this ray trace, you would have now path trace. This just is the same function, but now you have this ray cast, right? You get a ray hit, you get some color, okay. But now what you can do is, so let's say you get another like ray hit 2, which now the ray start. So what is the start position? That is the previous ray hit, and what was the name of the hit point, right? So hit point, and here you need this new random ray direction. So this you need to find. And this is the ray hit 2, and those things are needed here as well. So, and then you get color result 2, which is some color 2, and now you can do something like, let's call this color 1, something that color is equal to a mix of color 2 and color 1, I don't know, 0.7. This is up to you, what do you want to, how do you want to mix those two colors together. Maybe you don't care about like any energy conservation and just add it on top of the other, just add the two together, or you mix them linearly together, the indirect light and the direct light. It's up to you. Just see like what gives you a good visual effect, where it's visible, like where is the indirect light coming from. And this is actually where you need this normal. So remember, this result has also the normal in there. So there's probably random reflect, and you reflect around that normal, and you find a new direction. So this new random direction is that. So create a function random reflect, which reflects something around the normal. Now, do you need some other parameters here? I don't know. Think about it. What parameters would this function need? And then that would be pretty much it. Oh yeah, the averaging. So the averaging part is probably somewhere here. So this result is now your current color, and then you need to get as a texture the input of the previous color, which will be something like texture 2D or like previous sample, like some UV, right? And then you need to output a mix of the current color, the previous color, and this sample weight, which is the value you need to find based on this idea. So what is the sample weight here? Yep, on the CPU side, you need to have a counter. So what is n? What's the current n? How many samples have you taken in order to find this sample weight? Of course, you could also send n here and right here the sample weight, but well, it's up to you where you want to do it. Yeah, and time, don't forget time. So if you're always getting the same noisy result and it isn't changing, then remember that the random generator you write there needs some kind of a seed, and if you always give the same seed, for example the hit point, then it will always give you the same value. So you probably want to also use time to make sure that the seed is different each frame, or maybe the sample weight or sample like number, the n, could also be used. So each frame, the seed should be different. Okay, and like try with 0 bounces, perhaps you can even try like to just output the indirect illumination. Then you can see are you getting some good results here or not. And 1 bounce is enough, no need to do any more. Okay, I hope you like this more creative task. So no base code, use the previous base code. Still some interesting mathematical ideas. How to like not get this weird thing, but rather get this beautiful thing as a random value, and how to change a running average with new samples without having to store all the previous samples. And yeah, using the skills from previous tasks and creating this scene that really shows the indirect illumination of bouncing the rays around. And be creative, try out different things. You can find out what's right, for example, like how to blend those colors together in a correct way, physically based way, or just try something that looks cool with this color blending together, indirect and direct light. It's up to you, and have fun, and good luck.